Yeah, so I think, Jamie, you're going to share your screen.
Share.
Thank
Yes.
you. Then I will begin speaking, Dave. And I'm going to talk just briefly about Northeast trees, and then I'll sort of talk about stormwater at maybe the more strategic level, and then we'll turn it over. Then I'll turn it over to Jamie, and she'll start talking about more of some of the design element and low impact development examples. And the idea is to try to leave plenty of time for questions. I think that's a more interesting way, and you probably can go to our website and learn a lot about Northeast trees. So, Jamie, give me the next slide. There we go. So these are the sort of objectives that we want to try to achieve tonight. I guess it's tonight. As I'll describe in a minute, sort of stormwater, people come to stormwater from a number of different perspectives, and so sometimes projects are all the perspectives that I'll get into in a minute, and sometimes they're just one or two of them. So, but it is becoming a much more both necessary and desirable parts of projects, depending, anywhere from planting a tree all the way up to designing a large building. And low impact development or LID approaches are becoming issues that more and more of us are having to deal with. Next slide, please. So this is a little bit about Northeast trees. We've been around for a little over 30 years. Almost all of our projects today are stormwater related in one way or another, and we've been doing stormwater projects at schools and parks and various other types of facilities for almost 25 years now, I think, maybe not quite 30. And as I say, those are our primary areas that we work. We're either designing and building parks, or we're a design build firm. We hire and train local youth, often at risk for gang activity, and we try to provide both technology transfer to them as well as skills and a job. Oftentimes this is the local youth's first job, and our intention is to try to get them interested in landscape architecture, landscape design, construction, this sort of thing, and help provide them future jobs in those areas. If you want to know more about us, go to our website, which is northeasttrees.org. Next slide, please. So we're known for many different types of projects. Some of the ones that we are most known for are the projects we've done along the Los Angeles River. So we were really the first organization to do any significant projects along the river. We just in the center section that I'm showing here, we've planted almost 6,000 native trees along the river, which helped create then the desire for parks. We've designed and built about 25 parks along the LA River, from up at its headwaters down into the Gateway Cities area. And I should stop here and just say that, so Northeast Trees experience with respect to stormwater and just the projects that we do happens to be primarily in Los Angeles. So not all of the audience may be in Los Angeles County or even in the state of California. So I apologize that our perspective and experience is really in Los Angeles County, and so I'll be speaking to some of the regulations that we have here in California. But these types of regulations and interest for doing stormwater really now we see happening in Europe and other parts of the United States. So in any case, we sort of started much of our work back in the 90s along Los Angeles River. These are some of the parks that were built starting at that period. Now there's a multi-mile, tens of miles bikeway through this section that comes underneath the canopy of the trees that we planted along the parks that we built. So next slide. To give you an idea, here's a park coming up, Jamie. This next slide's a property that we did down in the city of Cudahy. So this is a little further south of the city of Los Angeles. And often our project sites start off looking something like this. So they're sort of degraded property, often owned by the public for one reason or another. We seek then state funding or local funding to then convert them, next slide please, into some sort of park. In this case, This is a linear park, and so the stormwater comes in at the top end of this park and then works its way through a series of low impact development treatments that Jamie will talk about, some of them not specifically to this park, but bioswales and rain gardens and other ways to capture, infiltrate, and filter the stormwater. And then any overflows are then released, in this case, back into the Los Angeles River. Next slide, please. So there are various driving forces that we see as an organization, and I'm sure that most of you see. First off, just the sort of the ones that all are basically related to, at least here in California where we live, but also worldwide with climate change and the increasing droughts, population increase and further development, which are putting stress on our local water supplies and our flood control capacity. And so you'll see then, because of that and just water quality, the County of Los Angeles has been violating the Clean Water Act, the Federal Clean Water Act for, well, now it's actually, I haven't seen recently, but in the past it had been violated for almost 20 years. And so many of these regulatory, at least for the clean water, the first 3 or 4 that I show on that second bullet, are all related to making and providing clean water that we put out into the ocean. But as I'll show in a minute, in order to meet our local water supply and sort of future needs for water, we're also focusing on flood control protection and water supply issues. So Jamie, next slide. So here in LA, and again, this is typical for other areas around the nation, the city of Los Angeles has what it calls its One Water LA plan. The other, LA County has approximately 80 cities, and each of the cities and the county within the County of Los Angeles all have adopted various plans that are similar to this one that I'm showing from the City of Los Angeles. The City of LA calls it their One Water LA. So next slide, please, Jamie. And the idea of this plan is to think more holistically about water and to try to make the region become water self-sufficient. So today we import most of our water, or at least most of our potable water from either the Colorado River, the Owens River, or from the state, the California Aqueduct Project. But we have a lot of water that falls here in the basin, and so the idea is to think about our water on a watershed basis. So you'll often hear people thinking and talking about this idea of sort of being holistic with respect to the watershed, and so that involves thinking about the flood control risk, the water quality, and then water supply all as one. So capture as much of the rainfall as we can, put it into our groundwater resources, pump it out for drinking water, send it to our waste treatment plants, and then recycling that water back for other uses. And so you'll see, for example, purple pipe coming throughout the county now. We use it on a number of our projects, and you'll be seeing more and more of that as time goes on. Next slide, Jamie, please. So I said that if you're anywhere in the County of Los Angeles, and again, this is likely to be the case also in Orange County and probably in the Inland Empire as well, agencies, both the counties and the cities, are adopting what are called enhanced watershed management plans. And so this is the boundary for the City of Los Angeles. The County of Los Angeles has about 10 of these, and the idea is to provide incentives to developers of all forms, so park developers like Northeast Trees, but people who build buildings and build roads and other types of infrastructure, to get them to have their projects be sensitive to stormwater, to water quality, and to flood control. And so those incentives, often the idea of an enhanced watershed management plan is to try to encourage people to use low impact development strategies. So next slide, please. And again, Jamie will talk in a minute about what we mean by LID. So I just wanted to show just not just on water quality or water supply, but flood control is a significant reason for the various agencies adopting some of the regulations. And so this is the sort of standard FEMA flood map that you would see down at the confluence of the Arroyo Seco and the Los Angeles River. And you can see most of the flood risk, according to FEMA, is sort of down just south of the city of Los Angeles. Next slide, please. But in fact, others, including the First Street Foundation, have been updating flood control or flood models around the country. So this First Street Foundation published in 2020 a flood model for the entire nation. And if you look at it, it shows much more significant flooding. And this is sort of, with respect to the city of Los Angeles, this is one of the current big issues, because as we've encouraged and are continuing to encourage housing and other types of development, particularly in the upper watershed, that's having impacts on the lower watershed and the lack of flood control. So next slide, please. So just to give you some idea of, so many of you likely are to bump into the need for stormwater through the regulations. So the standard urban stormwater management plan, those are areas under any development you have to achieve certain things. For example, you have to hold the peak storm, whatever that might be, 85 percentile storm, or one of the other ones, depending on exactly what your project is. Shall not exceed the pre-development aspect. So many projects have this need to store water. I think some of the things, Jamie, that you're going to show really, so we often think about these stormwater systems as a system made up of different components, where the components are trying to achieve, numerous things, including, cleaning the water, filtering it through plants to help achieve that, but also in some cases, the ability or the desire to store a certain amount of water on the project site prior to releasing it, or releasing it over a 24-hour period into the already sort of stressed stormwater system. And so you'll see that there's a number of requirements that come from just that one. And then, at least in the county and the city, in these enhanced watershed management areas, there are now requirements when you go through the planning process. You'll need to get a buy-off from the Bureau of Sanitation on their LID ordinance, for example, in the city of Los Angeles. Okay, Jamie, next slide. And so I just wanted to leave a few resources. Again, in your county or your city, there are likely to be resources that would be the first place to look. The ones that we use a lot here are the ones listed. There's not just from here in California, but from around the nation. I don't know if I show Tucson in here, but there's some really good work happening down in Tucson. And then for Northeast Trees in particular, the LA County Hydrology Manual and the LA County and City Low Impact Development ordinances and guidelines are really, even if you're not in the county or city of Los Angeles, those are very good resources to understanding this idea of LID, or low impact development. Next slide, please. And so I just showing one example of something that I use. As Dave said, I'm a recovering engineer, and so I still like to do engineering things. And the LA County Hydrology Manual has this flow and volume calculator that you can use, and we often use it at Northeast Trees to just get us, when we're in the pre-design or early in a project, we try to estimate how large the volume is for our particular project site, and whether or not we're volume constrained or whether we're going to be flow velocity constrained. And so the LA County Hydrology Manual and the tools that it provides helps at least us do that. And they're not hard to use, so you don't actually need an engineering degree, but one ought to read those. Many projects, including many of ours, will have an engineer associated with them for many of your projects where your engineer would just do these calculations. And for many projects that do have engineers from that are like a building or a road or something along these lines, then almost certainly the engineering will drive the stormwater part of that type of a project. For us, we're often building parks or other types of green infrastructure, and in those cases, sometimes we really are not being driven by the regulatory needs. And so we're not necessarily going to build a highly engineered bioswale, for example. But that's just for us. But we do find the the hydrology manual a useful tool. And I think with that, Jamie, it's turning it over to you.
Thank you, Mark. Okay, so from a design point of view, moving beyond a conventional approach to stormwater management, which is sheet flowing directly into a drain, which then goes from small to big all the way out into the ocean. It's about, from a design point of view, multiple functions when you choose to use LIDs or low impact developments. And especially the kind that Northeast Trees has done in the past, which from our point of view is beneficial because we are improving aesthetics, we are enhancing recreational opportunities, providing wildlife habitat by way of planting more plants and trees, improving safety in that it is known that in a natural environment, people slow down, especially pedestrians, such that they're not likely to trip over a giant grate. Okay, so practices to reduce runoff. So what we have to think about holistically, if you think for an entire site, like a campus, a medical facility, a hotel location, is reducing impervious surfaces overall such that water has opportunity to soak down. So within your code, if there is a minimum parking area, you do that, but you can do it within the building footprint. For example, you try not to have an exposed parking lot. Within the building footprint, you can put a green roof on top of the building if you plan ahead. You can have downspouts redirected into bioswales and cisterns instead of having downspouts going directly into an underground collection and then shunted away. You want to reduce compaction overall across the site. So you want to leave undisturbed areas undisturbed, and then you try to build on top of previously disturbed areas if possible. And for Northeast Trees, always plant more trees, because trees are a non-engineered but highly effective natural solution for managing stormwater. So for the built things, you have evapotranspiration and infiltration. The water doesn't just need to puddle down. If you leave the water exposed to the air, it will evaporate. So you want to give it time to do that. And in addition to that, you want to give time for water to soak in to the ground, which is infiltration. And that is why we use bioswales, rain gardens, infiltration dry wells, which are highly engineered solutions where it's a hollow tube going vertically underground that will hold water, and then the water will slowly soak down. Or plant more trees, because tree canopies catch and disperse raindrops over time. And then there are practices that convey runoff from larger rain events. So if you have overflow, there are designs where you can use vegetated swales with step pools or check dams such that the water will slowly go towards a drain inlet, and during that time, it'll slow down. Reducing velocity of water will increase opportunity for evapotranspiration and infiltration. And then this is the most highly engineered solution last, which is practices that protect or restore receiving water bodies. So these are the artificial wetlands. These are the open habitat restoration projects with additional erosion control to reduce dirt that enters into the water and muddies it up and reduces plants being able to grow because of the dirt clouding up the water. So we have also been advised by Barbara L. Hall, who is an engineer. So in a project, it is important to consider the feasibility of LIDs when you are selecting them. So if you want to do a green roof, this has to happen on the front end of the design, where you have to consider budgeting, you have to consider engineering for the additional roof load, you have to consider irrigation, because water must be pumped upwards, so that will be a cost that you must consider. There are space constraints on project sites that you also have to consider. If after putting in all of the buildings, all of the parking, all of the circulation, and you've trimmed back as much as possible, you end up not being able to have the square footage needed for a wide horizontal type of LID, maybe you have to end up doing a vertical insertion instead. And all of that comes down to cost. And when it comes to LIDs, the most important thing to consider that you must do is a geotechnical report from a reputable geotechnical firm. Geotechnical will give you information on the soil profile of the site, such that they can make recommendations for engineers to consider on how quickly water can infiltrate into the site. If you are on a site with a very, very high clay content, or a layer that is not permeable at all, so that is a bathtub effect, putting in LIDs will not help, because water has no place to go. So either you engineer it such that the LID punches through that layer to get to groundwater, or you use LIDs that slow down water and you focus on the evapotranspiration instead of having it infiltrate into the groundwater, where the water will end up into a conventional storm drainage system, but you give it a chance to evaporate back. So overall, you have to have flexibility and familiarity with various different types of LIDs, and a handle on costs for engineering and potential geotechnical reports that don't give you the result that you hope for. So starting from the rooftops down, this is a highly engineered solution. These are green roofs. These are best for stormwater filtering and heat island mitigation within a highly urban context. You must design them early. You have to consider the structural engineering. For plant growth, the media has to be 6 inches to 1 foot in depth, and the weight of this growing media is heavy. Deeper growing media increases the plant species choices available to you, which would increase the value and attractiveness of such a project to the client. It will require some irrigation to start the plants growing during establishment phase. So you must take that into account as a cost. And wind shear must be accounted for. Planting trees or large shrubs close to the edge is definitely not recommended. And the waterproof membrane of the roof underneath the growing media is very, very important. Research must be done for locally appropriate choices. But overall, these, if it is possible, a green roof is definitely one of those capstone projects for an architect. And plant choices can be done by consulting landscape architects or professional horticulturists with experience. So on the ground level, we have something that is a familiar replacement of a conventional feature in a campus. This is porous pavement. Porous pavement is where the grout allows for infiltration. And pavement types, thickness, the base course profiles are dependent on anticipated traffic load and desired water storage capacity of the base course. The gravel underneath the pavers function as almost a sponge, which will allow water that gets in to soak downwards. This is not an application for slopes, and it does require maintenance. It does require sweeping and vacuuming. So the client must be made aware of this, and maintenance manual must be given to them. We have experience with that. This is a Northeast Trees project at Benjamin Franklin Elementary, Glendale, constructed in 2017, where it's an outdoor gathering space. It could have been conventional concrete or asphalt, but it's not, because we want to be able to capture water on campus. Another very conventional thing is rainwater harvesting and reuse, going from small backyard rain barrels up to these very large cisterns. So this one is, systems should be sized based on the supply area and the intended uses. So some people can design it such that the cisterns can be tied into gray water use. So toilet flushes, washing machine overflows, that sort of things can also be part of a cistern system. Runoff should be screened and filtered. Notices should be made that this is a non-potable system. However, you can use this for watering lawns, for watering all landscape. It can be hooked up that way. Engineer the foundations of the cisterns based on the weight of the water harvesting system at full capacity. This is also very important if you happen to be at a site where there can be subsidence. And some local regulations may prohibit installation of such systems because you're not supposed to harvest and keep your rainwater. So be aware of that just in case for the permitting. Okay, this is another Northeast Trees experience project in Garvanza Park. So underground infiltration or dry wells, these are very large concrete galleries where water from a drain, instead of going into a stormwater pipe, it gets shunted into hollow concrete structures that are open on the bottom, where they can underground begin infiltration. Because this is not open to the air at all, clean out maintenance of 4 blaze of suspended sediments is very, very important. Do not use these in pollution hotspots because of the high risk of groundwater contamination. For example, Garvanza Park, right here, has the capacity to hold 2 Olympic-sized swimming pools worth of water. 85 acres outside of the park, well, the park and outside of the park are all being directed into the park. On top of the park, there are sports fields. So this is an opportunity in a project to have an LID, to have water infiltration and a public amenity. This use may be restricted once again due to the local geology. If the geotechnical comes back and you cannot infiltrate that, then it becomes a liability that you have to take into account. So rain gardens and bioswales. Rain gardens infiltrate water. Bioswales filter water as well using plants and substrates. Most of the time they are fairly interchangeable, but bioswales have a little bit more design going on into them. The most suitable sites have soils with higher percolation rates already, because you do not want to risk mosquitoes or other insect disease vectors due to standing water. So you have to do perk tests for potential locations. So what happens is it's a planter area with a dish shape. It's got a dip in the middle. It does have a drain inlet that is placed higher just in case there is a heavier rain event such that the water does not flow out of it. And as it soaks into the dirt, it's a combination of topsoil and gravel and other filter media. There are plants planted specifically that can withstand being submerged underwater for a foot or so in 48 hours or so, and trees such that the plants can uptake the water and at the same time filter out foreign material. And then the water is slowly cleaned as it goes into the groundwater. The plants inside the bioswale must be irrigated at the beginning of the first year of establishment. And this is a completed Northeast Trees project at Benjamin Franklin Elementary, Glendale. It shows an example of how you can add more trees, more plants into a existing campus. And at the same time, the planting space is not just a planting space, it is a working LID for stormwater infiltration. So I have two project examples. The first one is the Northeast Trees project. It was Los Angeles City's first green street, which was completed in 2007. It is located in the Elysian Valley neighborhood, just north of Dodger Stadium. It's a pilot project that redesigned a single residential street and public park to manage stormwater events. Instead of the conventional gutter to storm drain, underneath each sidewalk, it was pulled up and infiltration galleries were put in and the sidewalks replaced. So a project of this size, the treatment area was 1 to 5 acres, and the project cost was $500,000 to $1 million. And this is a multi-department partnership with Northeast Trees collaborating and coordinating between all these different departments. As you can see, on a municipal level, this is quite a partnership, as you can see, with City of LA Bureau of Street Services, Public Works, the City Attorney's Office, Urban Forestry Division, Bureau of Sanitation, because the water is entering conventional storm drains, and the LADWP. So here is a write-up in cubic feet, but basically the total runoff produced by a 3/4 inch worth of rain falling all at once, draining into Oro Street, is 53,000 gallons. So 65% of runoff was treated within the infiltration trench running underneath the sidewalks. So that's good. So that's what is underneath the sidewalk. There's 2 very large perforated pipes, and it's surrounded by gravel, and then the water starts soaking. So this is a project done by LA City itself. So this is the Glen Oaks Water Capture Project. It constructed the first 6 bioswales using the city's standard plans. It also used the company Torrent Resources dry wells. So these are very large vertical concrete columns that are hollow, and they're open to the bottom to allow for stormwater infiltration. So this is located in the intersection of Sunland Boulevard and Glen Oaks Boulevard in San Fernando Valley. The project was completed in 2016. So for this one, the funding is $500,000. The treatment area is much larger at 300 acres. And the estimated stormwater capture is 300 acre-feet per year, which is about 9.3 million gallons of water that is being captured and then filtered and processed and infiltrated into underground instead of immediately being shunted over to the channel. So the existing conditions prior to the project is hazardous street flooding during rain events. So the following photos are project progress. Bioswale locations were chosen, concrete was removed. Bioswale excavation depth was 5 feet, and then infilled complete with gravel. So the curbs have these inlets which catch the water. The water flows in and is slowly soaked in. The bioswales have plants planted also that will intake the water, and then they have street trees as part of the bioswales. So this is the Torrent dry well. Dry well drilling to the depth of 50 feet to get to appropriate groundwater infiltration. And then the insertion of the concrete sidewells. The dry well interior is usually empty prior to storm events. And then, so the dry wells capture the storm water. It looks exactly like a conventional storm drain inlet, more or less. And then the bioswales are capturing storm water in this rain event, as you can see here. One thing that you have to know in a highly urban context, but still in any context really where there are people involved, is that maintenance must be done. Trash must be picked out because people will litter. And the growing substrate might need to be replaced as the plants use up the soil nutrients. So compost, that sort of thing, might need to be added over time. And it should just not be allowed to clog up.
You really think that's the page?
That is the end of my section, and we are now open to questions.